What if we were to detonate the most powerful thermonuclear weapon in human history right on the lunar surface? Would a single, concentrated strike be enough to knock our satellite out of orbit, triggering global tsunamis and tectonic chaos on Earth? Or would we simply sign our own death warrant by turning the moon into a giant cosmic shotgun, blasting our planet with millions of meteors? Watch this video until the very end to find out why a real nuclear explosion in a vacuum looks nothing like Hollywood movies, and how one mistake like this could instantly knock our civilization back to the Stone Age without ever touching Earth's atmosphere. Let's slow time down to nanoseconds to watch the birth of a man-made apocalypse in every detail. The moment the circuit closes, the outside world is still absolute, dead calm. But inside the casing, hell has broken loose. Conventional explosives compress the plutonium core with surgical precision, triggering a fission chain reaction. This is just the fuse. X-rays from this primary blast instantly heat the thermonuclear fuel to 100 million degrees. Matter ceases to be matter, turning into plasma. For the briefest instant, we have created conditions that usually only exist in the hearts of supermassive stars. And only 10 milliseconds later, the metal casing evaporates, and the cosmos realizes that a new, deadly star has been born. The fireball begins its rapid expansion, and this is where the cruel and unfamiliar laws of the vacuum take over. Everything you knew about explosions on Earth doesn't work here. Your intuition will deceive you. The first shock is the nature of the light. We are used to seeing an explosion as a bright flash of visible light. But on Earth, that happens because X-rays heat up the air, making it glow. The moon has no air. Therefore, about 70 to 80% of the energy is released not as visible light, but as hard X-rays and a flood of thermal photons. This is invisible light that doesn't illuminate, it kills. The second difference is the absence of fire itself. Fire is a chemical reaction involving oxidation. No oxygen means no combustion. You won't see swirling tongues of flame. Instead, a wave of pure, distilled heat rushes out in all directions at the speed of light. On Earth, the atmosphere softens this blow by scattering the heat. On the moon, there is no protection. This thermal pulse acts like a laser. The lunar soil, regolith, is instantly heated to thousands of degrees. The top layer doesn't even melt. It sublimes, skipping the liquid phase and turning directly into gas. Stones further away melt instantly into glass. If our virtual astronaut were standing 50 kilometers from ground zero, facing the blast, his suit would begin to melt instantly. But here is the paradox of the vacuum. If he hides behind a large boulder, he might survive the thermal shock. On Earth, hot air would flow around the rock and burn the human. On the moon, in a vacuum, there is no convection. The shadow is absolute. If you are in the shadow, the heat cannot touch you. But don't celebrate yet. The weirdest and most terrifying discovery comes next. We're used to the main destructive force of a nuclear weapon being the shockwave, the wall of compressed air that flattens cities, snaps trees, and ruptures lungs. That is what makes the kaboom. But on the moon, there is dead, absolute silence. There are no air molecules to carry the impact energy. The plasmasphere grows in total silence. Our observers won't hear a roar nor a whistle. Even if you stood a kilometer away and somehow didn't burn, your eardrums wouldn't feel a thing. There is no wind. Dust doesn't swirl up before the blast wave, but this silence is a deadly trap. The lack of atmosphere, which saves buildings from being blown down, becomes a death sentence due to radiation. On Earth, The layer of air above our heads protects us like a meter-thick wall of lead. It absorbs gamma rays and neutrons. On the Moon, radiation flies unimpeded. A stream of neutrons and gamma quanta hits targets hundreds of kilometers away with pinpoint accuracy. It is the perfect directed energy weapon. Any electronics fry instantly, and the DNA of any living thing is shredded in a fraction of a second. It is a quiet, sterile death you cannot outrun.
However, the energy of the explosion doesn't just disappear. Finding no escape into an atmosphere, it finds another victim, the solid ground of the Moon itself. The explosion becomes a giant hammer striking the celestial body. About 10% of the total colossal yield turns into seismic waves, triggering what seismologists would call a great moonquake. And here, the Moon has another surprise. Earth is soft and partially molten inside, which dampens vibrations. Earthquakes fade in minutes. The Moon, however, is a cold, hard, solid block of rock. It is rigid. So after the strike, it begins to ring like a bell. Seismic waves will travel through the satellite's depths for hours. The ground beneath our observers' feet will vibrate with terrifying intensity. This vibration won't be as sharp as on Earth, but it will be endless and exhausting. Any lunar bases, rigid telescope structures, solar panel farms, all will begin to crumble from resonance. Even on the dark side of the Moon, thousands of kilometers from the blast, the ground will shake as if a freight train were passing by. At ground zero, a geological catastrophe is unfolding. The explosion excavates a crater. The solid rock behaves like a liquid. It splashes, creating a pit over a kilometer wide. And this brings us to the real threat to Earth. Millions of tons of vaporized rock, molten glass, and radioactive dust are blasted upwards. On Earth, air resistance quickly breaks the debris and it falls back near the crater. On the Moon, there are no breaks at all. Rock shrapnel flies and perfect ballistic trajectories. The exit velocity of the debris can reach tens of kilometers per second. The escape velocity for the Moon is only 2.4 kilometers per second. This means a huge portion of that ejected mass will overcome the satellite's gravity forever. The Moon literally spits a chunk of itself into space. A giant cloud of shrapnel, a swarm of micrometeorites, heads straight for Earth. For people on the surface of our planet, this won't be the end of the world. Earth's atmosphere is a reliable shield, and most of the stones will burn up, giving us the most beautiful and perhaps brightest meteor shower in history. But for our technological civilization, it is a disaster. Thousands of satellites orbit Earth. Communications, GPS, weather, military intelligence, and the International Space Station. This swarm of lunar rocks acts like a shotgun blast against delicate electronics. Even a grain of sand at 30,000 kilometers per hour carries the energy of a bullet. A nuke on the Moon could trigger Kessler Syndrome, a chain reaction of satellite destruction that would instantly blind and deafen humanity, killing our connections, navigation, and internet. We wouldn't destroy the planet, but we could blind ourselves and knock technology back 50 years.
Now, let's look at the sky. What will it look like? We are all waiting for the famous nuclear mushroom cloud, but it won't happen. A mushroom cloud is the result of convection, where hot air rises, pulling dust with it, and cooling to form a cap. In a vacuum, there is no convection. Instead, we see an expanding sphere, a blinding white ball of plasma growing at incredible speed. But because nothing holds back its expansion, its energy density drops very fast. Seconds after detonation, the sphere turns red, then dull crimson, and vanishes into the blackness of space. No billowing clouds, no lingering glow. From Earth, It would look like a short, bright spark, as if someone flicked a flashlight on and off on the moon. After the flash, only a cloud of fine dust remains, rising hundreds of kilometers up. Since there is no wind on the moon, this dust won't settle for weeks. Illuminated by the sun, it creates a ghostly, glowing halo over the blast site, a beautiful monument to human stupidity. And finally, the answer to the question that scares everyone. Did we move the moon? Did we shift its orbit? Will it crash into Earth? The answer is a definitive no. Even 100 megatons is nothing on a cosmic scale. The moon weighs 73 quintillion tons. Trying to move it with a nuke is like trying to stop a speeding Boeing by throwing a mosquito at it, or trying to move a mountain by sneezing on it. The law of conservation of momentum is unforgiving. The change in the moon's velocity would be so microscopic that even our most precise instruments couldn't measure it. The orbit remains exactly the same. We just added one more scar to the moon, one new crater among millions of others. But this isn't a victory. The moon won't take offense. It doesn't care. But we lose. The material ejected by the blast that didn't fly into space falls back down, and it is highly radioactive. On Earth, rain and wind wash away radiation. Soil absorbs it. On the moon, there is no erosion. That radioactive stain will remain there practically forever, unchanged. We will have turned a huge chunk of the lunar surface into a forbidden zone where no one can land for the next 1,000 years. Any future base, any mining complex in that area becomes impossible. This thought experiment teaches us a vital lesson. Our destructive power, which seems absolute on Earth, is just a weak spark in the universe. We cannot destroy the moon, but we can easily ruin it for ourselves, closing the door to the stars with our own ignorance. I'd be grateful for any support. Leave a comment, subscribe, hit the like button. It really helps the channel.